For all of human history, we have looked up at the night sky and wondered one simple question. How far can we go? We crossed oceans. We reached the moon. We sent robots to Mars and beyond. But one challenge stands above all others. Can humans ever leave the Milky Way galaxy? Our galaxy is vast, so vast that even light, the fastest thing in the universe, takes over 100,000 years to travel from one side to the other. And beyond it lie hundreds of billions of other galaxies, each filled with stars, planets, and mysteries. Leaving Earth once seemed impossible. Leaving the solar system once seemed insane. Leaving the galaxy? That sounds like science fiction. Unless the universe itself has shortcuts. These shortcuts are called wormholes. In this video, we'll explore why leaving the Milky Way is nearly impossible, what wormholes really are, whether they can exist naturally, if humans could ever use them, and whether intergalactic travel is science fiction or future science. This is the story of humanity's greatest possible journey. To understand the problem, we must first understand the scale. The Milky Way is a spiral galaxy containing over 100 to 400 billion stars, trillions of planets, a supermassive black hole at its center called Sagittarius A*. Its diameter is about 100,000 light-years. That means light takes 1 year to travel 9.46 trillion kilometers. To cross the Milky Way, light needs 100,000 years. Our fastest spacecraft would take tens of millions of years. Even reaching the edge of our galaxy is far beyond our current technology. Now consider this: the nearest galaxy to us, Andromeda, is about 2.5 million light-years away. So even if we could reach the edge of the Milky Way, another unimaginable journey awaits. With conventional rockets, intergalactic travel is impossible. So does that mean we're trapped forever? Let's imagine a hypothetical ultra-advanced spacecraft. Even if it traveled at 10% the speed of light, far beyond current tech, it would take 25 million years to reach Andromeda. Multiple human civilizations would rise and fall during that journey. At 99% the speed of light, time dilation helps, but energy requirements approach infinity. Shielding against cosmic radiation becomes impossible. A single dust particle collision could destroy the ship. Faster-than-light travel, as we understand physics today, violates Einstein's theory of relativity. Which brings us to a radical idea. What if we don't travel through space? What if we travel around it? A wormhole is a theoretical tunnel through spacetime. Imagine space as a folded sheet of paper. Two distant points appear far apart. But fold the paper and suddenly they touch. A wormhole connects those points. Instead of traveling millions of light-years, you step in one side, you exit somewhere else. Travel time could be seconds or minutes. This concept was first proposed in 1935 by Albert Einstein, Nathan Rosen. They called it the Einstein-Rosen bridge. At first, it was purely mathematical. But over time, physicists realized something shocking. Wormholes are allowed by the laws of physics. Not all wormholes are equal. 1. Non-traversable wormholes collapse instantly, exist for fractions of a second, likely occur at quantum scales, impossible to travel through. 2. Traversable wormholes, stable enough to pass through, require exotic conditions, theoretical but not forbidden. Only traversable wormholes could allow humans to leave the Milky Way. But there's a catch. A massive wormholes want to collapse. Gravity pulls their tunnel shut faster than light can cross it. To keep them open, you need something extraordinary. Exotic matter. Exotic matter has negative energy density, repulsive gravity, opposite behavior to normal matter. This sounds impossible, but quantum physics allows it. The Casimir effect shows that negative energy can exist in tiny amounts between closely spaced plates. But here's the issue. A human-sized wormhole would require planet-sized quantities of exotic matter. We don't know how to create, store, or control it. Without exotic matter, wormholes collapse instantly. So does that mean the idea is dead? Not necessarily. Some physicists believe wormholes may exist naturally. Possible sources include the early universe, quantum foam at the smallest scales, regions near black holes, dark energy fluctuations. If natural wormholes exist, they may connect distant regions of space. They could link different galaxies, or even different universes. However, we have never observed one directly. Detecting them would require noticing gravitational distortions, or strange lensing effects inconsistent with black holes. Some astronomers suspect certain anomalies might be wormholes, but nothing is confirmed. Many people believe black holes are wormholes. This is not entirely true. Black holes have event horizons, crush matter into singularities, likely destroy anything that enters. However, some theories suggest rotating black holes, Kerr black holes, could theoretically connect to wormholes, but intense radiation and tidal forces would kill any traveler. If a black hole wormhole exists, it would require precise conditions, advanced civilizations far beyond us, possibly technology millions of years ahead. For now, black holes are not safe gateways. This leads to an unsettling thought. If wormholes are possible, why haven't we seen anyone using them? The Fermi paradox asks, if intelligent life is common, where's everyone? Possible answers. Wormhole creation is too difficult. Civilizations destroy themselves first. Intergalactic travel is unnecessary, or they are using methods we can't detect. An advanced civilization might build wormholes near stars, hide them using gravitational cloaking, use them silently and efficiently. To us, their travel would be invisible. Let's imagine humanity survives long enough. What would we need? 1. Energy control. Power output comparable to stars, Dyson spheres or stellar reactors. 2. Exotic matter production. Mastery of quantum fields. Negative energy manipulation. 3. Spacetime engineering. Ability to bend and stabilize spacetime. Precision beyond anything today. 4. Navigation. Knowing where the exit leads. Avoiding deadly radiation or collapse. This is not thousands of years away. It may be millions. Wormholes introduce a terrifying possibility. Time travel. If one mouth of a wormhole moves faster than the other, time dilation occurs. You could exit in the past or the future. This creates paradoxes. Grandfather paradox. Causality violations. Some physicists believe the universe prevents this. Wormholes collapse before paradoxes occur. Others believe multiple timelines form, or self-consistent loops exist. If wormholes allow time travel, nature may forbid them entirely. If wormholes are impossible, are there alternatives? 1. Generation ships. Massive ships carrying generations of humans. Travel over millions of years. Cultural survival is uncertain. 2. Cryogenic sleep. Humans frozen for long journeys. Biological risks are huge. 3. Digital consciousness. Uploading minds into machines. Sending data instead of bodies. 4. Von Neumann probes. Self-replicating machines. Explore galaxies without humans on board. But none offer true human intergalactic travel like wormholes do. Here's a final twist. The universe is expanding. Galaxies beyond a certain distance are moving away faster than light due to spacetime expansion. This means some galaxies are already unreachable. Even wormholes may not overcome this. The universe has a cosmic horizon. If we don't leave the Milky Way early enough, we may be trapped forever. So what's the final answer? Short answer. Not with today's technology. Not even close. Long answer. Physics does not forbid wormholes. We don't know how to create or use them. The energy and control required are staggering. But the universe allows strange possibilities. If humanity survives, climate collapse, nuclear war, AI risks, cosmic disasters, then one day, far in the future, our descendants may step through a tunnel in spacetime and leave the Milky Way forever. The question is not just, Can we leave the Milky Way? Will we survive long enough to try? Wormholes represent the edge of science and imagination. They challenge everything we know about reality. Maybe the universe wants us to stay home, or maybe it's waiting for us to grow up, because only a truly advanced civilization can become an intergalactic species. Until then, the stars remain distant, but not unreachable.